Daniel Schiffman from the Coding Train has a book out, and it's called The Nature of Code. natureofcode.com. Please go check it out. You can buy the book ebook bundle, and it's mainly a donation thing. I highly recommend that you go and do it. But there is an available free option, which is the only piece of information that I truly needed, which was the download the book's code, which is at the bottom right hand corner of the screen. And if you just click that code, you go to, you download it, you unzip it, you go through the files, you go to chapter 9, and you go to Genetic Algorithms, Shakespeare, Fancy, Fitness. And with that, this is the information that we get right here on the left-hand side. This is his entire algorithm, or his entire code. Again, please go check him out. This is his original code. I take no credit for it. If I do, I'm an asshole. So, apologize for that language for anybody out there who, I don't really like to do that on this channel, or at least in this series. I don't like to use profane language because there's no real need for it. Let's change the language. I'm a butt if I ever take credit for work that was not mine. So, Daniel Schiffman, his original code, schiffman.net. Ooh. And in this, I'm going to try to figure out how to actually understand this. As a kinesthetic learner, I've said that multiple times, as a kinesthetic learner, just reading it doesn't really work for me. Somebody explaining it doesn't necessarily work for me. I may have the idea up in my head, but I need to be able to explain it, and I need to be able to apply it. Those are two things that are fundamental when it comes to programming for myself. And let's do this together. So, together. Setting up for a joke did not work there. So there's 3 sections: the genetic algorithm, the GA, genetic algorithms, Shakespeare, Fancy Feast, Fancy Fitness, not Fancy Feast, Fancy Fitness with setup and draw section, and even the display info or function. DNA section, a class DNA, and population class. Excuse me. Seems to be some functions in there. Okay. There is 120, 50, about 60, 120 plus 150 is roughly a little bit more than 300. So there's roughly more than 300 lines of code here. That seems like a lot. I have not dealt with something that large in this series yet, but if we just take it one step at a time, that's all we have to do. How do you eat an elephant? First off, you better have, why are you eating an elephant? That's a question that I have. Why would you eat an elephant? How do you accomplish something? You break it down. Okay? What is my end goal? What is my objective? I want to learn genetic algorithm. Next week, I'm either going to go visit family, or I'm going to be learning more about genetic algorithm, and I'm looking forward to doing genetic algorithms. Something that I've been needing to learn, something that I've been wanting to learn, but the best thing that I have right now is that I need to make up my decision, but I also need to know what it is that I want to do today. What is my goal and objective? So my goal and objective is, let's do that live. So what I normally do is I just open up my last notes from yesterday, 2019, June 28th. I copy, open up a new file, paste, and save. Now I'm carrying it over. Now I can modify it for the day today. Saving it in notes, 2019, notes, 2019, June 29th. And here is my here were my objectives from yesterday. To explore as much as possible with genetic algorithms, learn about genetic algorithms and how to create them myself for functioning projects, simply exploring and testing as much as possible for the next 2 days. And today is June 29th. It's at the very end of the day. It's already past curfew technically for noise, so if I can't really speak out loud, I can't speak aloud very high or very big, very loud. So this start and end date, it's already done. Next week, starting on the 31st, or no, the 1st, July 1st, 2019, July 1st, to, oh, I have it right there, July 1st, 2019, July 1st to 2019, July 5th. So next week, I'm going to be learning something specifically every single day. What am I going to be learning today? What are my objectives? What could I have done? And through Monday through Friday, maybe even Saturday, something I want to do is start using Saturdays as that and have Sunday as my rest day. Just boom, nothing else, doing nothing else. But for Sunday, that'll be my rest day. To explore as much, I know this for anybody who's new, anybody who is like, well, what are you doing? This entire channel is dedicated for me to learn how to program. Programming for me specifically on this channel is like karate, basketball, fishing, stamp collecting, whatever you want to call it. It is a structure, a system of activities that can channel my own thought processes and feelings in a productive manner. It will help channel my what's going on inside of me, which I don't understand fully. I believe I have autism. I've visited 4 or 5 actual professionals, 3 to 4, no, 3 in, or no, 4, probably 6, 3 at least in the private sector, and then 2 in the military. And there's a consensus about it, but they've never diagnosed me. It's easier to be diagnosed with autism or something at an earlier age, but the older you get, I don't know what the process is. I never even did it. But as a kinesthetic learner, for me to understand what's going on inside of my head, what's going on inside of my heart, what's going on inside, what activities are happening with my body, programming is helping me. It's not just programming. Speaking out loud, communicating, expressing what's going on in here. What's my thought process? Why am I doing that? And while I do this, I get engaged. And when I'm engaged, I'm more readily accepting or not just accepting, what I'm more readily available to accomplish the next task. Because I can just think about it all day, but if I don't have an event, all of what's happening right now that I'm communicating to you right now, this is all happening in my head, and if I'm not able, if I find like 1 or 2 challenges, I explode because there's no expression, because there's no ventilation. So doing this helps. Oh man. Yeah. So today, what I want to learn is I want to understand for today specifically, the goal for today is not just to explore as much as possible with genetic algorithms, to understand not in full or complete. I want to understand on how to apply I want to create my own genetic algorithm today. Today, I want to create my own genetic algorithm. That might be asking for a lot, but I think I am able to do that if I just break down the code line by line, start adding comments. What is this? Why is that here? Modifying this and that, testing it just slightly. I might only go for 55 minutes. I might go for 2 hours. Who knows? But the objective is to create my own genetic algorithm. Understanding. I think it's just understanding. I don't want to just continue to conceptualize. I need to apply. I've been conceptualizing a lot of things like, what about this? What about that? What about this? What about that? And I get caught up in myself. And then I wouldn't be able to escape what's going on inside of me, because I would go down a rabbit trail. I would go down a line of thinking, and then it gets too intense. I can't handle it, so I give up on acting on it. There's probably a better way to describe that, but you know what about this? What about that? What about this? What about that? And I start thinking, and then boom, now my feelings about going and acting start going down into depression. So I didn't ask for this. I didn't ask for that crap. I didn't ask for this. I didn't ask for the life that I have. I have the life that I have. What am I doing about it? That's the big thing. Is that I did not ask to be here. I did not ask to be alive. But I am here right now. So what am I doing with it? It's not even just doing things for myself, but there's other people out there. Why am I so focused on the things that I want to do? What if I do something that I enjoy doing, and then I can give that to other people who I can help them as well? So instead of just focusing on my own issues, What if I get out of my own situation, get out of my own self, stop thinking about me, and start thinking about other people? This is one of those methods of how I can do it. It's not just thinking about me. It's not just communicating with myself. It's as if you are here and I'm able to communicate with you right here, right now. And that matters to me. That helps. That helps me. I know it's like a lot of me, 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 me. When I'm able to heal, when I'm able to help, when I'm able to help myself, when I am able to be helped, I can help other people. The more that I have, the more money I have, the more potential, the more activities I can do for other people. The more, it's not even just money, the more time I have, the more I can do for other people. What I am doing for other people, that's a different topic. Am I doing things for other people? That's a different topic. That's a different question. So I need to really get out of my own head when it, like, what about me, 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 me? Okay, what have you done for another person? There's other people out there. So, with the line itself, this is what's happening, and I want to change what you see right before you, because I am not a fan of I'm not a fan of the size of the code. That is incredibly small. I want this code to be a lot larger, and I want it to be... So carrying on from yesterday, for those who are new to genetic algorithms, a genetic algorithm is simply having a process, and how to describe this, because I know that I can introduce it using a brute force method. Let's start with a brute force method. A brute force method is a type of genetic algorithm. It is a genetic algorithm, and just genetic algorithms as a whole. A brute force method is that we have our starting point and we have our end point. We know what those two are. Then we figure out what the best possible route is and what we decide which is the better route. Do we value, because there's 4 factors that come into a genetic algorithm. One of them is that we need to know what we value. What do we want to have? What's important when, if we were having a map, what is important for us to go from point A to point B, from one point to another? What do we value? Do we want to avoid traffic? Do we want to avoid speed traps? Do we want to have clear and open valleys that we can see left to right and wide open skies? Do we want to have a scenic route that goes through the city, goes through some towns? Do we want to get there in the quickest possible route? Do I want to get there at a certain time? That might change the route that I take. Every single one of those factors will change the route that I take. And to determine what we value, we will give the result that we test, whichever route we're testing, test this route, test that route, test this route, is this one correct? We're going to give each of these routes a fitness score. And this fitness score, the highest fitness score, is what is going to come out on top, and we will use for future tests. So the 4 factors that are important are generations, fitness score, population size, and mutation rate. And I'll go in order. A generation is a group of tests. That's all it is. It's a group of tests. It's a group of applications, and then we get a result from it. So if we have, and using the Shakespearean fitness, the code right here in front of us, is that the total generations that it took to create this line, that we knew what this line was, we were just trying to figure it out using randomness and then narrowing it down to this exact phrase, to be or not to be. It took 217 generations, meaning, well, not even meaning. Each generation within this code has 150 test results. These test results have start with a basic random generator. Then there is a mutation rate for each and every single result or every single application to give us a new result. It's a slight modification of 1%. We could change it to 5%, 0.1%, or any number that we find to be true. If we have it too small, we will have a very consistent line, and we won't find enough change, enough permutations to find out paths that we didn't know before. But if it's too random, if the mutation rate is too high, we might not be able to find enough consistency on going towards our route. We might want to go forward, but then if we want to go left, well, let's mutate again. Left, 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 let's go that way. It's like we might be going in the opposite direction. So we need to have enough consistency to develop over time, and we need to have enough mutation rate to find possible other paths that might be better than the path that we're going down. So a mutation rate, 1%, is a usual generic number. Depending on the situation, you might want to increase or decrease, but we're going to go with 1%. So each generation holds a set population size, and within this population size, we have a number of results. Each one has a slight mutation based off the last one or based off the prior one. So mutation, 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 mutation. So we have 150 test results. Now that we have these 150, whichever has the greatest fitness score, the highest fitness score, or whichever is most fit, whichever path we found to be the highest scoring path, we're going to take that path, and we are now going to use that base as the basis for the next generation. So as that is the new basis, we have our highest score. Now we're going to use a mutation, 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 mutation. We're going to change result, test. So now that we have this new basis, we've created 149 other results with a slight modification, a slight mutation. Then we take the highest score of that one, we use it for the next generation, and repeat. And then we take on this third generation, we take the highest score, on this one, number 49, now it is our number 1 for generation 4. And then we figure out that number 30 in generation 4 is our highest scoring path, so we take number 30 and use it as our number 1 for generation 5. And we continue this process until we find our result. That is a brute force method that we are trying to seek out an actual objective. We know where the end goal is. With a genetic algorithm in general, just a genetic algorithm, is that we do not know what our end goal is. We have objectives, we have guidelines, we even do know what our we may have an idea of what that end goal is, but we may not know exactly what it is. So what we want to do is we want to figure out what the closest answer. We might say that, well, it's in Texas, but we don't know exactly where it is. Well, we have some ideas. It's not near a gas station. It's not near planes. It's within a metroplex. It's within this. We have factors. We have. It's a lot simpler than the way that I'm putting it, but there's just other factors, other principles, other boundaries that we're giving it. We don't have a specific set point, so it's going to continuously, for genetic algorithms as a whole, is that it is going to try to always seek out the highest fitting result, and then use that for the next basis for the next generation. And it's one that continuously evolves over time. Now, eventually, it'll set in its own path, it'll set in a certain way, and then it will, you'll start seeing that maybe once it continues going down the line, it won't change the prior results. I'm talking about a different topic, so remove what I just said for the last 10 seconds. I started introducing another algorithm, and that's a little bit more complicated, but that's in whole, genetic algorithms, we're always trying to seek out the best or most fitting result, and we continue trying to seek it out. So a brute force method has an end goal in mind. There will be a set amount of generations that will happen. Other generations might never have an end generation and continuously try to evolve. So it might take weeks, months, years, decades before we can actually think of it like life forms. There's certain generations that happen. We do try to figure out what the highest fitness or whatever is most fit within this generation, and it breeds, and then it breeds, and it breeds, and it breeds, and it breeds. And it's not just about breeding anymore, because I don't really like that example because it uses genealogy. It uses your genes as what is most fit, and when it comes to mating, it's not necessarily whomever is most fit. It's not whomever breeds with whom. It's not necessarily that. I don't like that phrase, but I do like it like a business. If you have a business idea and you have 150 people within the same population, using the same population size, same mutation rate, same generations, is that we have 150 people applying and going out and trying to start a business. We figure out that only 3 of them out of 150 make money. 1 of them makes more money than the other 2. So we will use this one who made profit more than anybody else, and we'll use that idea how to make money, not the person, but the idea. And we'll use those principles, those activities, those connections. And then the next group in this next generation will have all the available resources for the prior generation. And then all of them will go out and try to make money using this method. They will all do it a little bit different, mutation rate changing, one result over another, change. We get 150 results. Let's just say now 50 out of 150 have now made profit better than the last generation. Not perfect, it's not great, but now we have a better way of doing it. So we'll take the highest performing business model out of the second generation of 150. We'll take the top performer and we'll use it for the basis of the next generation, generation 3, as number 1. And then this new generation of 150 people will use that as the basis for them to go out and try to make a business. Let's just say 76 people now make money using this process. We may even get where there's now 150 of 100% of all of them are making money. But there might be one that's making more money than anybody else. So we need to always continuously seek out a better way of doing things. Seek out a new way of doing it. We all need to have, because the business model you might be doing right now might work for now. Next year, there's going to be new topics, new people, new activities, new technologies. And if you are not constantly updating and going with the flow or even testing, doesn't mean that you'll be the most popular every single day of your life or every single year of your life. But you will have the opportunity to get yourself back out there and then seek out more money, more profit, more connections, more friends, more relationships, more success, more wealth, health, love, fame, fortune, and freedom. So there's more of what you can do. You're going to have those ebb and flows, and that's how life works. You're going to have some expansion and some contraction. But what the objective is that you always want to try to seek out more expansion and reduce the amount of contraction. So when you go for another expansion, you have even more resources, more leverage, so you can go even further. And this is how the rich get richer and the broke become more broke. It's the difference that makes the difference in the quality of people's lives. This simple activity of testing, experimenting, changing, modifying, seeking out newer and greater ways of doing things. And not even just the way that you do it, but also getting out of your own comfort zone and seeking out other ways of doing it. Maybe the method I'm doing right now with YouTube may not be getting the amount of views and clicks that I need. But I care first and foremost, and I would love to be as much of an entertaining person and educational person as possible to every single person that views this video. It's impossible to cater to that idea. I cannot possibly ever give 100% satisfaction rate to any audience. And if I do, that is an anomaly. It seldom, if any, happens. The first and foremost thing is to be as entertaining as possible to the most amount of people, and be as entertaining to the most amount of people. And then I also have to take into account that I need to also be learning through these videos, because that's important to me. That's a value that I need to be seeking out. It took me about 20 minutes to describe genetic algorithms and the importance of it, which I think is, again, a quicker way from doing it yesterday, from yesterday and the day before. You can even think of it, a genetic algorithm just like the McDonald's franchise. McDonald's has a certain way of setting up the entire business, where to set up the business, what type of people you need to operate the business, how you need to set up the fryer, where you need to put the drive-thrus, how many, where and how far do you need to do it. Each and every single thing has been measured by the McDonald's franchise, and that's how they make their mountains of cash. Is because they've been testing and testing and testing how to do it, how to be the best franchisee's owner, period. And McDonald's is not about fast food, it's about real estate. Because where you put your business is going to determine how much money you receive. If you put it on one corner versus another, it's going to change the flow of traffic and how easily it will be for one person to go to your shop, to your restaurant versus another. So again, that's why they make the big bucks. Because that's the biggest decision maker. that's the money maker. Flipping a burger is not a bad job. But if you want to make big bucks, you have to think a bit more global, a bit more meta, and then you need to go out there and apply it. How are they doing it? You need to be more meta, and you need to be more specific. There's a lot more conceptual things, but the first and foremost thing is you need to be out there and acting. If you're not where you want to be, go out there and change it. You change your results by changing you. When you change, everything else changes for you. Jim Rohn. Okay, so what I want to do first and foremost is I want to change this. This I do not like. It is too small for me. So the create font, I'm just going to do a lot of assumptions here. Courier. I don't see courier. Where is courier? Huh. Target to be or not to be. Draw. Display info. Best phrase. What I want to do is actually change the canvas size to not 600, but let's go with 1,000 by 750. Well, let's do it the same ratio. So it was 600 and 200. So let's go with 1,200, which is going to be pretty big, by 400. We could, no, let's not do it that way. Let's just increase it by 80%. So, 80%? No, increase, is that true? Okay, I know what I meant to do. Double it and then reduce it by 20%. I know that's weird, but increasing it by 80% apparently. So let's do with 600, which is the X, and then 200 was the Y. 6 times 1.8. Yeah, 1.8. That's 1080. That's pretty cool. 1080, that might be too big. I might need to reduce it down to like 75% or 50%. Let's go with 60. Now I'll do it this way. 200 times 1.8, 360. Those are numbers that matter in a video, a YouTube video, or like a 360, 720, 1080. Yeah, video qualities on YouTube, or video qualities period. Wow. See, dang. Okay, you need to go away. So, I like this. What I want to do is I don't need it to be that wide. Yeah. I can reduce it by, let's just say, 60%. I can make it 60% of what it is. So 1080. Let's go with it. Yeah, I like it. I want to go with the original. So 1080 times 0.6. That's not it because I did something different. 1080 times 0.6 is 648. Could just go with 640. And then, 200 divided by 600, so 0.33333, copy. We'll do 640 times that number, 213. Play. So it's exactly the same number. So I didn't change anything. Nope, I changed nothing. So I'm going to make that the original 600, but I'm going to make that 750. Whatever. I'm going to make this 500. Save and play. Okay. I like it. I'm going to bring it in a little. No, I'm probably going to have to push it away. So what I want to figure out is how to change, because we have certain functions. The setup, which is the initial, draw, which is constantly updating, and display info, which, again, by just my assumption, is literally displays current status of population. It literally is printing all the information for us. So what I want to do is I want to change this from a lowercase t to a capital, 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 capital. Okay. Best phrase? Where's best phrase? Oh. Okay. Best phrase. What I want to do is text size. I want to make this from 16. Double it. Text size is 64. Gonna double all of it. Answer 2040. I'm gonna have to change the location at where they are printing, but I really want to increase the size of everything. The text size is going to go from 12 to 24. The text size for this one's going to go from 10 to 20. And I think that's it for the moment. Save and play. Okay. Wow. Okay. So all that I need to do is just... Oh, that's actually a pretty smart idea. Huh. If I want to increase the size, I don't have to have a section on the right-hand side. All I have to do is just... Yeah. I'm going to make this a little bit bigger. I'm going to go from 800. And why? I'm going to go with, yeah. I don't need to have all phrases be on the right-hand side if I'm going to have it the way that I'm having it right now, because I don't want it just as wide as possible. I just need something. I could bolden it, but let's fix the left-hand side first before I do anything else. So the text location, I could double everything. I can make this 40 and then make this 60, doubling everything. 40, 75 times 2 is going to be 150. 150. The XY of all these things is going to be at, hopefully this is going to be correct, if not, whatever. Save and play. I changed one section. Whoa. Best phrase, I need to keep in the top left-hand corner. So let's reduce that back to its original location. Bunch of testing. So text size, correct. Text answer is going to be, I need to make this, okay, 20 left-hand side, but 150 doesn't need to come as far down as possible. It can actually go back up to 175. Yeah. Yeah. It's a little clunky. Like, it's a little too close to the very top, but I kind of like it where it is. I'm very okay with that. Very okay with that. Okay. Text font. F, fill, text align, left, something like that. Okay. Now, what I want to do is go for text size. Yeah. Total generations, I'm going to bring that down from keep that way. Actually, I can bring it up just a little bit, so I can go with 120. The average fitness, I could bring this up to maybe 140. It was originally 15 apart. What if I make it 20 apart rather than 15? Because I know I doubled the size of everything. Let's go with that. So let's go with 140. This is 170, which is, again, an additional 15. An additional 15, so I'm going to make this 20, which is 160. And then 185, I'm going to make it 180. So, on the left-hand side, it works. Probably need to give it like a little bit, 5 spaces or so. Maybe just another 10. Another 10 might work. Best phrase, answer. We'll make this go down from... We'll make this go down to 85. And then we'll bring these over, these down an additional 10 or something. And this original one, we'll make it 130. 1300. 130. We'll do 20. No, 30. So 160. 190. 210. I might want to go down to 25. That looks a lot better. No, it doesn't. No, it does not. So I'm going to come back up and I'm going to make this go back to 75. I'm going to make this go back to 120. Yeah. This will... See, why did mutation rate not go down Oh, because that's by 20, not by 30. Okay, that makes sense. Let's keep this at 130, and this will change it to 220. I was thinking that it was 30, but it was 20, so that was my fault. Okay, I kind of like that. This needs to, yeah, that quote needs to go down 10. Everything needs to go down 5. Let's make this 80, and then I'll change it. So we're at 5. Let's go with 85. We're at 10. I kind of like it. Kind of, not much. I'll go with that. Okay, so by 10. So everything is pushing down by 10. All the phrases. So 140, 170, 200, 230. Save, play. Okay. Yeah, that looks actually pretty freaking decent. It looks really decent. Yeah, and what I want to do is I want to push all those, like all phrases, I want to push that on right below mutation, the same distance between this one, the big phrase, the current phrase, and total generations. So that distance is roughly, because we have to take account of size of the text, excuse me, is roughly 55. So if we go from 230, I'm going to go from, because 450 is the x, this is why it's on the right hand side, I'm going to change that to 20, and I'm going to change it from 230 to 230 plus 55, which is again 285. Nice. 285. So I'm going to click save and play. It should be on the bottom left hand corner. That looks pretty decent. What I want to do is I want to make all the phrases. Wait, how does it do that? How does it print how it prints? With that equal distance. What I want to do is I want to actually minimize that distance. Okay, well, I want to make this 295. Just make it a little bit bigger. Click save and then play. Yeah, that's now let's go back to 285. 285 I like. Okay, save, play. Okay, so what we have currently is a lot better than the original one. Little tiny adjustments overall over time. So I don't need to have this space. Text all phrases semicolon slash forward slash n. What does that do? So let me go to processing. Processing.org. Forward slash n string. Nope. Oh! Forward slash n creates a new string. Yes, it does. Split tokens. Okay. So what's going on here is split tokens. Split tokens, despite the bad formatting, the data is parsed correctly. The comma as delimiter, I don't understand what that means. I've seen it multiple times. I just don't understand what it means as of right now. As delimiter means to break whenever a comma or a space is found in the string, which is what delimiter means apparently. Unlike the split function, multiple adjacent delimiters are treated as a single break. So string s equals a bc comma d. What? That's weird. So what if I need to do is I'm going to copy, I'm going to go to a new file, new, paste, and play. So I'm literally just copying the code. That's not right. Oh, yes it is. Okay. At the bottom left-hand corner in the console, you get to see that it's an A and a B. So print line A. That's weird. What's going on here? Okay, gotcha. Copy. Paste. I don't want to save it. Play. Okay, so 4 values found, A, B, C, D, in the console in the bottom left-hand corner. So, okay, despite the bad forming, a delimiter split tokens. That's not what I'm looking for. Okay, so it's just a different, yeah, I was off. I was way off. Okay. Yeah, it's not, I thought it's what we needed. It's not what we need. What we need, what else do we need? Split tokens, how do I detect a new line in a string? Left shift. What does, oh, avoid line, so it's a line break. Okay, it is a line break. Oh. Dang it. Okay. Okay, let's do it this way. This entire site, processing.org, we closed this form on 2010, June 18th. So, again, you can't do anything with it, but they still have it up, which I am very grateful for. So I get past different strings and want to avoid a line break. If one of them contains a /n, it messes up my program. Wow, this guy sent spelling. To maximize portability, you should search for the both /r and /n, since different operating systems have different combinations of one, the other, or both. If you want a space between the lines, put a space between the last two quotation marks. So let us do it this way. So I'm going to copy and put it into this new, which I already closed out. So new, paste, play. Oh, look, I need to look in the console. Test, test. Huh, what does that mean? Replace all. That's weird code. That looks really weird. One of those reasons of like, how do I deal with it? What does that even mean? It's literally foreign language to me. So breaking it down just a little bit more. What if I remove this /n, /n, clicking play? Oh, ooh, nice. Okay, so population.allphrases. That's what it's doing. Okay. /n, creating a new line, creating a new section. What happened here is that it says all phrases to be or not to be. That's interesting. Not to be or not to be. It's not the phrase. It's that it literally printed on the same line as the all phrases section. All phrases, new line, plus population.allphrases. Now, could you do this exact same thing by also putting a comma or a plus? I don't know. I don't think you could. So what I need to go is I need to go to the class population or whatever population is. So I'm going to go to population, which is a class, and I need to go and figure out what all phrases is. So I'm going to find all phrases. Hopefully I spelled it correct. Yes, it's a string all phrases, a string everything equals quotations, integer display limit equals minimum of either population.length, comma 50. Why? I have no idea. So a for loop of integer I equals 0, and then so for integer I equals 0, so it's literally just, it starts at 0, and then just if I is less than the display limit, and the display limit is that we're only going to have a population, either our population has regardless of whatever the population is. Okay, I understand this a little bit more, because again, where are the comments? I want to see a lot more comments here. List values of list population values with from current generation. So this one line, integer display limit equals the minimum, either a population.length, either it's less than 50 or it is 50. You cannot we're not doing the most. We're not trying to anything that's beyond 50, it doesn't do it. It doesn't do that. There's a better way of doing it. I could be blaming that it's nighttime, but no, that's my fault. I didn't explain it correctly. Minimum, nothing more than 50. Boom. That's exactly all I just needed to say. Nothing more than 50. So display no more than 50. Well, what I want to do is I want to display no more than like 10. I don't need that much. 1, 2, 3, 4, 5, 6. Why that? Why not? Let's move the canvas size up to 800. Save and play. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only need to show 10. That's all I need to show. So in population, I'm going to come down, list the population values from current generation, display no more than 10 values, population values. So I'm going to change this to 10, and I'm going to change the canvas size depending on how far down. So I'm going to go over here. Let's just go with 700. Well, I have to go down to 650. I kind of like that. I like having a little bit of space at the very bottom. So we'll keep it like that. Clicking save. Now we know a little bit more about the code. So, and I am modifying it as we go. So it is really cool. So for this section is that we are in the for loop. We're going to continuously when we are displaying all of our phrases, it is constantly just showing 10. So, no, what am I doing? So for integer I equals 0, starts at 0, and as long as I is less than the display limit, I plus plus. Okay, so what's happening here is that it goes, oh, that is really cool, I think. If this is how it's going on, it's printing one line, then it's printing another line, and another line, up to 10. Once it gets to 10, then we remove everything that we just shown, and then we post it back. Is that what it's saying? Because return everything. String everything, return everything? What does everything return? I don't know. I'm actually taking the literal definition of what return means rather than actually what it means in processing. So let me figure out what it means in processing. See, this is actually pretty good progress. This is pretty good progress. I might just go for a little bit longer and then I'll be done. But wow. Yeah, just a little bit more, a little bit more, a little bit more, a little bit more. So in processing, return processing. Wow, that's pretty cool. All I had to type in my search engine was return, and it automatically gave me processing. Huh. So return integer value. Okay, description. Keyword used to indicate the value to return from a function. So the value that we are getting right here, I believe the 2 point is, if that's correct, what if I do this and I comment it out? This method must return a result of a string, of a type string. Oh. So everything is a string, and then we're, oh. I didn't notice that before. So everything is what we are also adding. We're adding to every time in the for loop to the value everything. Oh, that's amazing. So all phrases, when we call this function, I guess, this function, is it a function? This phrase, which is, it's because it's both a function and a variable and a value. Is that what it's saying? All phrases. Wow. Huh. Okay. See, trying to understand it. Hmm. Again, I did modify a few things. So let's go with a few other things. I do not know exactly what it's trying to do here when it says the word return. Because, again, keyword used to indicate the value to return from a function. The value being returned must be the same data type as defined in the function declaration. So, everything is a string, so it's a string. Is that what it's saying? That this is a string, and so this is a string, so this must be a string? Or is it saying that we are adding to a string, and then when we return it, we must return it back to its original position? But I think it's just that if we return string, then everything, its use is a string. I don't know. Functions declared with void can't return values and shouldn't include a return value. So we are using return because this function, it is a function because of its parentheses specifically. String is a not a declaration. What is it called? A data type. I'm assuming that's what it is. Quickly searching for it. Data types. Yeah, Boolean, byte, character, word, integer, long, float, string, etc. So it is a data type. String, a data type. If it was void, there would be no value that would be returning with all phrases. Because all phrases, if it had the word void in front of it, it means that it is not it's not a variable or value. It does not hold any value. So return, if I understand this correctly, is that the value, all phrases, is both a function and it is returning, and within this function it is returning. It is setting all phrases to whatever everything is, what this variable is. So if I can explain it this way one more time, in a better way. This function string, all phrases, the data type being string, the function being called all phrases. Within this function, there's certain activities for us to figure out what the value is that we are going to return back to this phrase. Because if this, it's in this phrase, this function now has a value set, everything. So it's going to set everything to a certain thing, and then we're going to return all phrases, and that's the value that it puts out. If there was a void instead of string in front of this function, then we could not return any value to the function. This function's value is everything, not the variable everything. If it had the word void, there would be no value that it holds specifically, just a list of activities to do. Which is so interesting concept. I'm glad that I took the time to figure that out, because that's very fascinating. So I'm going to click save, because we're returning things back to normal. Going to click play. Boom, there we go. So I am at the end of my time here. I've only went for an hour. I think it'd be very interesting to go longer, but I am hitting a wall, and I am tired. I need to go to bed, all that great stuff. So what happened here is that, to summarize what I did today, is that I described what a brute force method was, genetic algorithms as a whole. What I made a list of, or I modified what goal I was trying to achieve today, even going to my goal list, or to what my goal was, is to create my own genetic algorithm. In a way, learn more about genetic algorithms. There is something fascinating there, is that I didn't learn anything specifically about genetic algorithms, but I learned more about programming. Even though I failed to achieve my goal today, what I did learn how to do, what I did understand today about programming, specifically in processing, but a little bit more in general in programming, is that within processing, if using a void, if we're creating a function, we can give a function a certain data type. If we don't want to give it a certain data type, we will put the word void in front, and it will just act out a certain list of activities or commands within that function. If we do give this function a data type, string, integer, float, character, whatever data type we want to put into, we want to set this function as, when we use the return command, it's going to set the function value. If I understand this correctly, I might need to change this later. We're going to set this function value to whatever we put as in return. So we're going to return, which means to set the function value to whatever everything is, to whatever that variable is. Okay, so hope that was entertaining. Hope that was something for you. If it wasn't, then I'll wrap it up very quickly. So it's one of those things that I caught myself saying yesterday or the day before, and it's very true. It's like, I hope this was something for someone. I hope it was entertaining. Hit my freaking teeth. I hope this was something. I hope it was entertaining. I hope it was enlightening. I hope it was educational. I hope this was just something, I don't know what it was for you, but I hope it was something for you. I hope it gave you something. And if it didn't help you, if it didn't aid you, if it didn't give you anything in life, then fortunately, we're at the end of the video, so I will quickly get you out of here as I stumble upon my words and drag this on as long as possible. So thank you very much for being a part of this. Please post your comments and questions and concerns right down below. Please hit that like, share, and subscribe button, because that would greatly help me out, this channel out. And while you enjoy the rest of your day, I will see you next time.